100, everybody wants to build this. You know the potential of this one, like cost, like 2030. You see large startups on this dark AI. Any guesses how many billion dollars? Really, no, not there yet. Maybe companies like Nvidia, they get that because of everybody from all the major cloud providers who invest on Nvidia because of the GPUs. But just for this agents, building agents, AI systems. Any guesses? 500 billion, yeah, little higher. Yeah, what research I saw, $200 billion in another couple of years. It's going to grow. The last one. Okay, so power consumption to run AI labs. So we saw that it took almost 30 GPUs, right, to train a model. What would be the power consumption? Let's say OpenAI running a lab or Bedrock, the Google systems, right, or Nvidia. How much power consumption in megawatts? 1,000, yeah. 20 megawatts. It's actually same as to run a small, more local Gramatra full of power for is a lot of time, a lot of energy. Okay, let's, as I said, let's start with understand what internals are, right, with LLM. I think since you guys, some of them are stats, so I just start off thinking for other experience, please bear with me for a couple more slides. Okay, so core components inside the LLM, what it is, right? So when we give a prompt, right, so when we ask for it, so just started trying to tokenize. It'll just understand the words token by token. We'll see what token is. And then it sends it to the transformer block because the machine doesn't understand the words. Right? It has to convert into numbers. And the numbers, it try to connect. It's not like simply when you say how are, then it has to predict as you or how are people, something like that. It has to relate. So that's where it pass it on to multiple transformer blocks to find the relevant next set of words predicted, and then it has to analyze based on this reasoning, and finally it gives the output data. Right, so that actually is a non-literal output based on other parameters that we give. Right, like a sampling strategy, we give a couple of parameters. Like temperature is one of the parameter and attribute we give, meaning how close the answer can be. Can this be like some generic answer, or is it has to be more accurate based on the real time data? Right, and also give. Then let's talk about CPU versus CPU. So this is another critical factor we need to understand. So most of our programming language start from assembly till the latest programming language, compiler based. It's all runs on CPU. Right? So, but why the GPU got into the we need to understand why what difference the GPU makes run these LLM operations. So CPUs basically more for this arithmetic and logic operation, right? And some memory aspect. And also it helps to manage the resources, not only memory, but input output. It helps to send right to this persistent storage or network operations. And also it is for it does some parallelism because we have a multi-core process. Yeah. So it actually helps to handle some parallelism, but not that complex operations. So that's why it is for most of the less heavy tasks. It is for GPU where it is more for the parallel operation. The reason being because of 4 cores, it has thousands of processing cores. So they build with multiple processing parallel capacity, and it also does a lot of matrix designed to have a lot of matrix multiplication kind of thing. And it also helps to have a deep learning and neural networks, connects the dots like a graph relationship kind of thing it builds. And it has a high memory bandwidth. It comes with, let's say, when we say billions of parameters, it has to have a good RAM, right? So memory, in memory to do the fast operation. So that's why they choose GPU as an architecture for most of the models. But still, you see, you remember what model that runs only on CPU? No. Chinese invented this. DeepSeek. Yeah, so they run in only on CPUs, but still people don't believe because we know how the quality of Chinese product. Right? So they still not very much into this. But okay, so now let's before getting into that, we the traditional monitoring what we do, right? So we always How many of you use top command? That really tells us on the CPU what is the top process which is running on the Linux, right? So which helps us to find out where the CPU or memory is, why the system is slow. Or we go to task manager and find out what is the CPU usage, right? And we kill some of the process which is not. Similarly, for GPU monitoring, if we are hosting a model, our own NVIDIA servers are GPU based machines, then NVIDIA provided a GPU exporter. So to give a background what exporter is, there is an open source Prometheus is one of the open source time series characters. It's a CNCF project and they come up with a lot of exporters. It works with a lot of other technology like Kafka, basic Linux, databases. So those are called node exporters, right? So node exporter where you just install the agent. It scrapes all the metric and push it to your Prometheus time series database. And from Grafana, you can visualize this. Similarly, they have this open source NVIDIA GPU exporter module, which you can install it on the ECU yourself, hosting those models and training it without using any SaaS product. Then this really helps. And this particular out of the box Grafana dashboard, you can just import it so we can visualize completely. You can see, so you can see clearly what processor that this is using and what is the state of it, and also what driver version and CPU utilization and the power consumption, fan speed, temperature, and GPU clock speed. So this really helps us to find out whether we have to increase or throw more GPUs in it, and if the time is slow down and we get an inference, right? So we have to reduce it as what is the cost whether we have to come down. So based on our requirement and planning, we can leverage this to get. Okay, so next, I think in the data flow perspective, so we saw that input will get encoded and transformers process it and send it decoding and send our human data with formatting in it. So there is a one more aspect in this is called contextual understanding, right? So as you all know, when you start asking the questions, right, prompts, you'll keep remembering what was the answer provided, what was the ask and everything, right? For until you complete the session. So for that, it has a transformer layers with a huge amount of memory, right? DRAM. So that's what it holds for the contextual memory, and also you can persist through vector database and other things, but still it holds a large amount of before it generating out. For example, so when we ask what is machine learning as a prompt, right? So once that is the tokenization, the question is broken into tokens. Each of these, including a question mark. Question mark is a right, and then it stores internally as a numerical vector. It's called embedding, meaning what is the relationship between each of the words, right? So with the semantic meaning, it assigns to a number. And then it passes to the multiple transformer layers, like analyze the relationship. What is the relationship between machines? Are they really asking about a simple machine or machine learning is an IT terminology, right? And then model builds a deep contextual understanding. Then finally, based on the trained data, with whatever from the encyclopedia of the web, right? So then it converts and then provide a detailed answer like machine and subset of artificial intelligence and provide you all the points. Okay, so this is where, right? So tokens are not just words, right? Sometimes a space can be a token. And because of the space that we prompt we generate, right? Multiple spaces, it actually costs a lot on the model who is running the model. The space is like when I don't know how many, you guys know how compression works. When we compress a text file, you achieve more than 95%. Anybody know how the compression, how are they bringing down the size? If you compress a JPEG file or a binary file, you don't get that just because of the space, right? They just avoid the spaces and repeated characters. So that's the algorithm of compression. Similarly, if you use a space in the prompt, that again, I mean, that's how we have to communicate, right? That's how we write, but there is no other go. They spend a lot of dollars for that. So the whole word or part of the word, the punctuation, weird character fragments, even the dash, question mark, everything is a token. So in this, I like pizza is like a 4 to 6 token. Even the dot at the end is a token because it has to understand that it's the end of the sentence. Right? So how to observe this? A simple Python code. You can see that with transform auto tokenizer. This is a basic Python module with the llama 3.38 billion token. Right? So just give a tokenizer, pass this. If you just print the number there, so it's the number of tokens. So this is a simple way to measure what is the size of input token. Yeah, that's where GPU has to store all tokens. And if you want more tokens to be processed, burn more VRAM, virtual memory in the LLM. So now we know how this has been working. So where we are heading into, right? So the LLMs are mostly the fuel for these AI agents, right? When we started this LLM processing flow for a simple chat bot, when we feed the input, LLM generates output. And next, what we did is one point Darren mentioned. So we just pass a bunch of documents, as a policy documents or whatever the Wikipedia, or even a lot of legal companies, right? The entire law of constitution. So we just pass it and ask questions. So it will just provide a response. And with the RAG, right? So we have a customized or private LAN tools running on our intranet, right? We provide access to that tools and give a database. So it gives with a more meaningful responses. And multi-model workflow similar with if you want to validate multiple models, which one is better for us? Maybe we don't have to use the same GPT for all kind of processing, right? So we can use a simple transform. Or if you want to just analyze the inference, what is the mood of the person who's asking the question, tone of the prompt, right? So then we don't need a full LLM. So multi-model architecture. And advanced AI agent architecture is where the agent with all the tools and the MCPs and all those things come in. But the future of AI agent, right? That's what all industry is moving towards. Is the multiple agents, in fact, through agent-to-agent protocol, right? So where the personal assistant in your phone talk to a travel agency agent, like you just give a, if you want to do a travel, right? It completely manages your itinerary, book tickets and hotels and everything, right? So that's like agent to agent communication. That's what businesses are moving towards. Yeah, I think this is some of the parameters we talked about. So weights and biases, we want to predict based on how the output should be, right? So if you want to tune how the LLM has to be, so you can set these weights, all the architecture and weights and biases are input parameters, how do you want prompts to be responded. Tokenizer we saw just to split the prompts into tokens and the transformer blocks. So now there is another concept evolving called quantization, right? So I tried to run GPT-4 open source model in a 16 GB machine, but it crashed because it needs at least 16 GB because you need to host operating system and other processes, right? So this quantization actually helps to reduce the model footprint in the memory, right? So for if you want to run an 8 billion model, I think mostly like 4 to 6 GB of RAM is sufficient with the GPU. But for more than like 30 billion and everything, you need a more memory. So that is really reducing decision by they have an internal mechanism of storing instead of doing a 30-bit flows, they are reducing it to 8-bit integer. So if you reduce the so then why do we need like the same GPU OSS has a 8 billion model as well as 16, right? So why do we need to go for this? Still with the accuracy, right? Same accuracy. So they also have some efficiencies managing the memory, and but at the same quality. I mean, there will be a loss obviously because it has more learnings, right? So if you're just trying to reduce the amount of processing, so there will be some quality loss, but not significant. Yeah. So it enables the greater scale if you want to run parallel workloads and everything with a minimal hardware. So try this out. There are a lot of hugging face models with this quantization available. So we can explore how we can benefit with this. Okay, now we understood what LLM, how internals are and how it's being processed. Any questions so far? So now let's understand what how can we gain insights into the model. So that's what I researched about it, right? So we talked about the transformer layers and embeddings in decoding, encoding, and everything. But none of the these papers or anything available to get the internals of it. How the internal LLM pass through the layers and get the details of it. Right? So whatever the observability we are going to see and which is available in the market now is about after the fact, right? So LLM is still a black box. So there is no maybe some research efforts, maybe somebody doing the research, and soon it might come because of I mean there is not much open source LLM models are available now, right? So we have to teams are building busy building agents rather than creating new models rather than expanding this black box. So what we are going to see today is just with the use of LLMs, what are the things we can observe and how we can improve the model and prompt it, right? So that's what is available in the market. So what are the unique challenges, challenges to the LLMs where it's just a silent failure. So we don't know when we ask for it, what is the reason for a failure, right? So we might have some less number of hardware, and like I said, so it's fine for a big model running in a small machine, right? So we don't know why it's failing unless you go and monitor what is the resource usage and everything, right? That is one of the challenges. And the second one is the performance drift. So you train a model for certain data. And over the period, if you run this in production, you keep getting multiple diversified requests in the data, right? So it has to keep learning it. What happens is there will be a drift, right? So in future, there will be new technologies coming, new standards coming, but the train model is not trained for it. So it's actually the quality of the output it produces will deteriorate. That's what we call it as a model drift or a performance drift. And unbounded cost again. So there is a parameter that we have to pass when we wanted to call an LLM, right? So it's called max tokens. So that is important. If you don't give a max token, it will actually generate pages and pages based on the prompt. Right? So that will actually go for a lot of cost unless you don't host by yourself. So that is also another thing. We have to monitor cost as well. And the reasoning, again, it has to go through multiple workflow. When the AI agent is there, it has to make decisions and call multiple tools. If there is an issue comes in, it has to call a tool one first, get the data. Okay, this is correct. I have to make a call to another tool to confirm that and call tool three to make the changes, right? So we don't know what is happening in the what layer. So we have to understand why it made the choice to execute this decision. You might have heard something like the recent model is deleted the entire production database, right? The news keeps coming in. We don't know why it happened. Right? Currently, we can use that model in confidence. So that is another reason. And the compliance risks, we are going to see a separate session on the security part of it. So for that reason, as well, we need to observe. Okay, so core metrics, right? What are the things we have to monitor with this LLM? First, the quality metrics, where understand the accuracy. So when we train it and when it produces the results, what is accuracy? This is where the human intervention is needed, where we have to make sure to do constant feedbacks to make sure what accuracy is, and we can start understanding, keep tracking the metric over a period of time. Similarly, the hallucination rate, again, this is again manual intervention needed to understand this is right or wrong. And other material like automated scores based on the response it produced. It's called bilingual evaluation, right? Meaning how the tone of the response, right? Does it have like another human speaking? Right now we see yesterday the AWS reinvent they announced a Neon 2 model as like speech to speech, right? Text speech to speech model and all. So how is it like producing a human kind of results? Or just a machine, right? So people can really understand. How many of you have seen this GPT produces data text, right? Response will always contain dashes. Yeah, you can clearly differentiate if somebody written coming from in the mail or any public post, right? There's a dashes in between, you know, that's from GPT, right? I think this is the 5.1 model. But so that's one of the metric we can clearly understand what that is. And there's a recall oriented. So the route is higher for perplexity kind of application because that gives the factual data rather than machine generated. So it goes and refers different sites like Wikipedia and other sources and provide the right information. That's another score we can track from the model getting produced. And then typical reliability metrics like latency, error rate, and the API rate limits and time and stuff and running. And safety metrics, how prompt injections have happened and the jailbreak attempts. So those are things you can measure that. Cost metrics, number of tokens, input number of tokens it produces, how many retry attempts they were trying to do the same thing, but still instead of taking it from the cache, it just use a compute to produce the result. And the governance metrics in terms of audit logs, just for safety purposes. Okay, so now we understood what are the things to measure from these LLMs and what are the stages of this observability, right? So first and foremost, we have to evaluate its output. So it happens only through the evaluation of manual measurements and then tracing, right? So what are the calls it makes? Like even within that, if you write a lang graph or a lang chain based Python module, so what are the different methods it call to take the decision, right? So that is the importance of the tracing part. Then prompt testing. This is you have gone through if you are building an agent where refine your prompt right completely and recursively because the output is not up to the par that you are expecting. So then you have to tweak the module to make the right decision and also provide a right output format, maybe in the JSON and API contract and so on and so forth. So that needs some prompt testing capability. And then RAG monitoring as well. So just to when does it use your own proprietary data and making a decision. And finally, fine tuning oversight. So see how the metrics are improved over a period of time. So this is like you optimize everything, and final stage is just like continuous improvement. Keep watching and refining this, right? So these are the different stages of the LLM observability. Now we've seen what to monitor. So what was internal and what to monitor. Now what are the tools and frameworks available? Let's see what tools. So plain old open telemetry, so which is well-known second, well-maintained in CNCF. So how does open telemetry help here? So as soon as you pause to make an LLM call using OpenAI or Anthropic or even Olama Python frameworks, right? So it produces the results in terms of how many requests we made and token counts and error occurrences. And also it will provide some gauge kind of metrics where you can create active connections and concurrent requests and the histograms in terms of latency and token usage. So this directly get output from the response from LLM SDK, and you can push it through a metric exporter, right, in the open telemetry. Similarly, traces will have a span, and also the span will have an attribute, so you don't have to push the metrics. So the span, you can do that. And also, it gives a context of what method call, right, as a typical distributed tracing variable. Even this really helps if you have an agent making multiple tool calls, you can pass the context to get a complete chain of communication. So we are going to see a demo. So what I've used is Prometheus to store the metrics and the Jaeger for traces and visualize this in command. So this is a pretty straightforward. You don't get much information, but at least from if you have a Python code or a Node.js, so you can actually clearly how the call flow works. Right? So this clearly tells us. So the next framework is OpenLLM Metry. So this is just like expansion of what OpenTelemetry was. So they provide an additional deeper insights in prompt engineering, model performance, and everything. So this gives some governance around what the default open telemetry metrics are. So it gives us you can add additional feedbacks and everything. So that's what these guys do. We'll have a semantic conversion, like what is the prompt input and output, what are the count model responses it captures by default all this information. Also performance metrics in terms of token usage, cost, error rating, and trace context as well. And also the ecosystem compatibility. It also compatible with regular open telemetry collector. You just have to have a SDK installed in the program and send it to your hotel collector. Rest all by default, whatever the exporters you configure, like processor and export. So another open source framework is LangFuse. So this is again the latest version, couple of hours ago, it's like 3.137. The LangFuse, apart from SDK, they also provide another right-hand side management module. Instead of like Prometheus and other stack, what I mentioned, so you can send it to LangFuse. So they have a cloud SaaS version, and also they also have a local set of self-managed version as well, where you can post it in Docker or Kubernetes or AWS. They have a Terraform for AWS, GCP, and Azure, where you can throw a compute and you can store it there. So basically, what they do is a typical whatever metrics we saw in OpenTelemetry. Metrics traces, that's there. But whatever you can actually annotate, ask feedbacks, and you can actually log whether it's a valuable input or not. And they also give a prompt versioning. So you start with a prompt and you want to make a change, right? So you want to make the change in the prompt. It maintains the versioning, like how the source code is. So you can continuously improve what the prompt was given. And if you want to switch back, the old one was giving better response. I've like multiple times, right? I lost the prompt because after a couple of few weeks, still the response was back. So started to go back. This really helps us to go and take the older version and restore it back. And also they have a module called LLM as a judge. So manually, whatever feedback that you enter and even the user responses, it keeps collecting it, collating and provide you the score. Which prompt or which one is a better. You are evaluating multiple models. Which model is better, right? So this really helps us to do that. So this is their backend architecture. So apart from SDK, if you start sending it, so they have a LangFuse web server, which is Nginx, and they have a cache as well. And there is an async worker which keeps pumping the data to the ClickHouse data store. And they also have a blob storage as well. They use WinIO if you run locally, and use S3 or any other object storage. And they have a for Postgres for regular tracking of how the API is being used. So this is, and also they have optional playground, right? And they have a chatbot as well. You can find models and test it. So this is the lang fuse backend architecture. So another tool. So you've seen three: Open Telemetry, Open LLM, and LangFuse. Now LangTrace. So this is another open source framework, which pretty much gives what LangFuse provides. Right? So you can see this is a dashboard, but I attempted this, but somehow in the local it was not working. So I don't want to use a SaaS. We just want to show everything local. So only LangTrace. This is a from their GitHub page, but they have this capability of providing the accuracy, cost of the tokens, the latency, and all the other API requests that we make in the chain, LLM chain, and the evaluation side and which model is better. And you can see the prompt version control, and they have a playground and can choose right which model you want to test against. So this is another one called OPIC, which is from a company called Common. So they also provide the similar capability what LangFuse does. Similar trace and debug capabilities have a built-in metrics. You don't have to extract all those metrics and send it like how we are doing for OpenTelemetry. You just operate with their framework annotations. So they take care of automatic instrumentation there. And they have an experiment tracking and also help in monitoring real-time dashboards of production. So just to give a quick comparison, right? So provide what are the key areas that we want to choose the right one for us, right? That's why it just provided a comparison out of these five frameworks that I took for comparison and evaluation. So the focus was, is it open telemetry compatible? Because that's going to be the standard, right? The whole industry agreed that hotel is going to be the observability standard and semantics and attitude formats, spans and everything. So you can see hotel compatible, mostly everything OPIC doesn't because they have their own protocol and they send it to their backend. Mostly the LangFuse, LangTrace fits into our category of all like LLM tracing, prompts responses, local cost tracking, evaluations and quality analysis, production monitoring, hotel compatible, right? So that's where LangFuse and LangTrace really meets our requirement. Any questions so far? So out of all these tools, do we have some sort of, can we get an idea from you or from your perspective, like which would be the right tool for what kind of rack-based applications? Right? I understand that different types of applications have produced different types of outputs. So the semantics differ, everything differs. So how I know one size doesn't fit all, but how do we approach that? Saying that okay, for this kind of an application, this would be the right open source tools that we could use. So that is very important. We've seen in multiple sessions on unified observability. I even for the demo, I try to bring everything in the Grafana side, right? So store it in Prometheus as self-managed data lake where all our other observability data, telemetry data comes in. But some of the additional capabilities these days, LangTrace and LangTrace and OPIC build, right? That is not there in Grafana. Maybe we have to develop that capability because they build a wrapper around it. So you'll see in the demo that I'll show that. So they build a separate UI for this. Typical trace view where you get a span and call tree view. Apart from that, they also track. You can annotate that. Okay, so this call is this is better or this is a prompt and everything. You can actually give a feedback. I don't think you can do it in Grafana. It just actually visualizes. It doesn't interact with us. Right? Like an interactive dashboard. So and that stores the data. And later, if you want to evaluate the model, you can see always go and see what is feedback that we had, what is the prompt that we provided, what is Excel, and how much accuracy it was, accuracy and hallucination percentage that we can track, which is not there in Grafana. So but to start with, until the Grafana has that capability, I would recommend we need to go with a separate tool like LangFuse or even for agentic AI or plain LLM evaluation, that should be the one. So you can clearly see where if you want to move towards open standards, so I don't want to do all these. I finalized with the model. I'm going to go with like open source GPT-4 OSs or Golama. Then we can go with this open standard, that one below, right? So where you can either use open telemetry, open LLM, where just get the basic, there's the GPU metrics and the number of tokens, what is the cost and everything. But if you want to evaluate the model, right, you are building a model for your own organization, and you need to evaluate and train the model and pass the rack and have AI agent capabilities. then probably go with the other side, a complete platform which gives a separate UI for now. Maybe we can, once you finalize everything, you can go to the open standard. So I see this in two ways. The one regular, if you have LLM is not a separate part of the application, it's part of the ecosystem. Right? That's what I see. So like earlier, a Java, Golang API does, maybe that is replaced by this agent by automating some of these things. That's how I see it. So it's a part of the application enterprise architecture. So regular observability and security controls outside for the entire ecosystem applies there. But specific to this one, like how the Java Golang being watched, right? So we had an agent installed. The agent actually part of the runtime, which collects actual observability metrics and give you that. Similarly, what here, similar SDKs are available. There is no dedicated agent here. So we still have to write some lines of code because we are really relying on Python right, as of now. So there, it provides some kind of visibility. That's what we are in early stages now. So it gives us what is the number of tokens being passed and what is the cost we took. And with the help of other GPU monitor and all, we can monitor the hardware resources. And the rest are as to the accuracy and everything. Right? This is not automated at this point. It is completely manual. So even in the cloud providers like AWS, everyone, if you bring in a model and talk, we have human has to feed it, test. Okay, I tested this. This is the accepted result, but it gave me this. So accuracy is like 60%. So that's how we collect the feedback and review a overall trend rather than like giving out of the box solution. So it works in anywhere. I mean, even if we were new, right? So in the development or your local laptop or you have a separate machine, so it definitely work everywhere, wherever LLM is. So it's just a matter of wrapping whatever the SDK, wherever your LLM runs. So now we try to see what are the single model, right? How we can observe, evaluate, and everything. So what is beyond a single model? Some agent does it. So it definitely it makes a lot of tool calls and MCPs and everything. So that really helps us if we have these kind of frameworks with open telemetry compatible and other frameworks as well. Helps to trace how the agent works. And just to make sure we have this agent to agent communication is the feature, right? So the MCP protocols and A2A protocols. So those things you have to start understanding and watch any new developments come in. So that definitely helps to understand how the communication and troubleshoot where the issue is. As I said, for agent observability, so start with infrastructure, computes, RAG, and TB layer because we introduced it for the relations and all. And model layer that we've seen now. Agentic layer, right? The A2A protocol, command executions, tool usage. I think the NI10 clearly gives us, if you see from the development side, so you can see the number of tokens passed for each and how tool calls made, what the prompt for that particular tool call and everything, right? So that really shows that. And then orchestration layer, where we have multiple agents, how the orchestration layer behaves from one agent response and how does it make other calls and all that. That's also important. And finally, the usage model. So when the finally end user uses this application, right, the business function, how that is being translated, because always the observability, the outcome of that should be there. How are we matching it with business? Not like the technical visibility alone, right, to the business, what value that brings to the business. So best practices for production, if you want to start using it, just start with the core metrics. What are we seeing? The number of tokens, cost aspect of it, and automate the evaluation part. So we've seen tools support that. Instead of manual, see like anything workflow or any other automation part just to verify some of these. So we can release some of the validation side. Have a feedback loop, right? That is very important to continuously improve the capability of the model and have a proper prioritize that traceability as well, just to find out where. So what are the demo that I set up? So it's there in the GitHub page. If you guys want to try it on your own, feel free. Yeah. So personally, this is just an evaluation that we are doing. So I haven't used in any of the clients or production systems yet. But in general, in the observability side, so this unified observability and these open source frameworks like OpenTelemetry and all really help a lot. It help customers to set that up from cost effective way of tracking down those request rates and those things like that. I mean, future we're expecting more. This is going to come back together. I think it's going to be agents. So with this, I conclude my session. So just want to say, we did a lot of distractions, right? I want to say stop scrolling and start rolling to make some meaningful difference. Thank you so much for the wonderful questions and being here. And thanks for the opportunity.